people definitely need to define their enzyme activity units, and please give it in moles and not megs, so I don't have to track things down. So what am I talking about? Well, so if I go into the freezer, I can find these little like product pamphlets for the different enzymes that we order from like NAB. And so enzymes are like reaction speeder uppers. And if I look at this one, so for T4 DNA polymerase, so it's going to put DNA letters together, although we typically use it in a different way. But I can see that it has 750 units and 3,000 units per mil. That big U is for units or activity units. Okay, if I go to TEV Protease, this has 1,000 units and 10,000 units per mil. But what the heck is a unit? So if you look anywhere on here, you're not going to find what a thinking unit is. So you go online, right? Okay, so now you go online. So let's look at this. Okay, so T4 polymerase. So the protease, TEV Protease, is going to cut proteins. So obviously these two things are like super duper different. But we're both talking in terms of like units and units per mil. If I go to T7 polymerase, it's saying, okay, a unit is the amount of enzyme that will incorporate 10 nanomoles of DNTP into acid-insoluble material, so basically just like actual DNA, in 30 minutes at 37 degrees Celsius. Okay, well, what about for the TEV? Okay, here we have that one unit will cleave 2 micrograms of BBP fusion protein, blah, 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 in 1 hour. Okay, so these clearly, a unit is like a totally different thing. So what the heck is a unit? Well, basically, it's whatever you want. A unit can be like anything, and you just have to define what the unit is. And so this can get really, really complicated because then you're like having to figure out like what the heck this thing are. And you have to track them down because they don't make it easy. All the things I'm going to talk about have to do with like how much doability stuff you have. So like total activity would be like how much total doability do you have in your thing. So like you buy 1,000 units, you have an activity of 1,000 units. But then you have like the enzyme activity, so it's like units per mil. So this would be like 10,000 units per mil. But then to get the specific activity, you're gonna have to do more work because the specific activity is like units. It's like units per like meg or whatever of your protein. So you have to actually like use the mass of the protein, and this is gonna the specific activity tells you about like purity and that sort of thing, and so we'll get into what all of these means. Now back to the rant. Like as I'll show you, like they're saying the substrate in like micrograms, but if you're like cutting 1 tag per like thing, you need to talk about moles. You need to talk about like actual copy numbers and not in terms of micrograms. So I had to like track all of this stuff down just in order to figure out like what was the molarity of the substrate, because I care about the molarity. I care about like I have copies of my protein. My protein's not going to be the same size as their substrate. And yes, so this today will be a bit of a rant, but also a talk about what enzyme activity means, what specific activity means, and like what enzyme activity units are, and how we can convert between these things. And hopefully this will help people, and if not, at least you can get a good rant out if this is something that really drives you crazy as well. When we talk about activity of an enzyme, we can kind of use the term loosely in more of like a qualitative way. Like if an enzyme is more active, you might say, okay, well, like if you had the same number of copies of the enzyme, if you had a higher activity, it would be able to do more than if it had a lower activity. But now things get confusing because we can use these specific terms to define things. So when we talk about like enzyme activity in the official sense, then we have to take the volume into account. And as we'll see, this is going to mean that if you dilute the enzyme, then you're going to be diluting the activity, or you're going to be reducing the enzyme activity, but not the total activity. And so the activity is basically how much ability to do stuff is there. And so we need some way to say, like, what are we talking about doing? And how do we define what we're doing? And this is where the enzyme activity units comes in. So we can define both the enzyme activity as well as the specific activity, which is going to also tell you about purity and stuff, because it's going to take into account like the mass of the total protein. So if not all of your protein is, you have like a really impure mix, then not much of the protein is actually going to be the enzyme. So it's going to have a low specific activity. And we'll get into this more in a minute. But all of this is going to be defined in terms of your enzyme activity units. And these really can be anything. So there's like an official activity unit, like a CATL or whatever. I have never heard of anyone actually use that. Basically, everybody just defines a unit as whatever it is. And even if you had like a set definition of moles per minute or whatever, it all depends on your reaction conditions. And so that's why when you look at like the definitions of units, when you look up one of these like documents, you'll see that they have all the reaction conditions very spelled out, because the activity of these enzymes is going to differ in those. So the enzyme activity unit is defined as the amount of something, like the amount of the substrate that can be converted. So the enzyme does its thing to this much over time. In these specific conditions, so with this buffer, with the salt concentration at this temperature. And so if you were to like, it's kind of like if the car salesman or whatever, if they say like, oh, we get 60 miles a gallon or whatever, but that's like on the highway, or that's under ideal conditions. So you're not going to get that ideal conditions all the time. And so a lot of times we have to take this into account if the activity units are given based on like a reaction done at 37 degrees Celsius or something, and we want to do it overnight in the cold room. So that's something to take into account as well when you're talking about the units, as well as that these enzymes might have different activities and different buffers and that sort of thing. But the activity unit is basically a way to have an idea about how active your enzyme is, how much you need to add, various things like that. And so when you look up the protocols for things, they might say add this many activity units. Unfortunately, they often do it like 2 per mgs or something, which isn't always helpful because of size differences. But anyway, so the specific activity is going to tell us like the copies of substrate converted into products, so the moles. Then this is just like a common one. There could be, you can have different versions of these, but basically it's going to tell you the copies per time per mg of your total protein. So some of which is going to be the enzyme. Sometimes it's also reported in terms of units per mg, because your unit is going to combine this mole and this min. So the unit's telling you about the amount of substrate per time, and then the specific activity is telling you about that divided by the total mass of protein. And so this is often, you'll see this a lot when people are like purifying activities, especially like in olden papers, you see this a lot, where if you are purifying it out, you're going to be decreasing the amount of total protein. So as you get purer and purer, then you're going to have more copies of this per the same amount of mass. So if you were then to take these, like this protease, and you were to mix it with a protein with the site that it could cut, the purer your mixture, even though, so you'd have the same amount, if you have the same amount of enzyme in all of these things, you get the same like total activity if you were to add all of this. However, you have a lower mass here, so you're going to have a higher specific activity. So as long as you don't change your volumes, you're going to have the same enzyme activity, and you're going to have the same total activity, but you're going to have more copies per mass, so you're increasing the specific activity. So as you purify an enzyme, the specific activity should increase. If you were to dilute your enzyme, now you're still not changing the total activity, so you still have the same amount of stuff doability, but you are decreasing the quote unquote enzyme activity, even because it's getting more dilute. So because your enzyme activity is divided by volume or whatever, so it's like enzyme activity is often given as like units per mil or that sort of thing. Whereas specific activity is given as units per meg. So they're basically both kind of defining the amount that you have in terms of in terms of the volume or in terms of the mass. And so this is, so it might seem kind of unfair to the enzyme that you're saying, okay, I diluted you, now you're less active. So from the individual molecule perspective, however, we often talk about like, it doesn't really make sense to to me at least, like I feel like we still talk about like the enzyme itself, like a single copy of the enzyme. You can have a more active enzyme, but if you dilute it, then it can still be more active in terms of like that one molecule's power. However, in terms of like the enzyme activity, it would be lower. So it's kind of just like a numbers and a definition game type of thing, because we often use this term like activity in a more qualitative way as well as in a quantitative way. Typically, if we're talking about like enzymes, you see in less so than just like enzyme activity, you'll see like specific activity or and enzyme activity units. Those are really the two big things to keep in mind and to know about. So where does this come into play? So now this gets me back to my rant. There are different types of proteases, and some of them are really specific and some of them are non-specific. Some of them are really specific, and one that's really specific about where it cuts is this TEV protease, and it's so specific that we can stick a tag on the end of a protein when we're recombinantly expressing and purifying it. So we stick the instructions for making the protein into like a plasmid, so like and then we're going to stick this in cells to make the protein for us. And so a plasmid is just like a circular piece of DNA. But we can add a little bit of extra information at the end that's going to put on a affinity tag, something like a his tag. So some histidines in a row that's going to bind to a nickel column. A strep tag, there's different types of tags, but this is going to help us with the purification step. But we usually design them so that there's this protease recognition sequence between the tag and the protein, so that after we use the tag to purify the protein, we can then cut off that tag so it's not on our protein. And so we, in our lab, a lot of us use this TEV protease, and so it recognizes a specific sequence, and so we put this specific sequence of DNA letters that'll make the specific sequence of protein letters, so amino acids, and then TEV will recognize it and cut it. And so with each of the proteins, we're purifying different proteins though. And so if different people in our lab study different proteins, and even the same people in our lab, we study multiple proteins. And so we're going to have proteins with big proteins and little proteins. And each copy of the protein though, we're going to have a tag. And so if we had a lot of a little protein, it would have the same mass as not as much of the big protein, but they would have it would have way more tags and way more things to cut off. So when we're talking about, this is why I was getting into the rant, and I'll get into more later, is that we want to know like how, if we're talking about like how much of the TEV protease do I need to add, how much of the scissors do I need to add, well, then it makes sense to think in terms of how many moles do I have, like how many copies of these do I actually have to cut, rather than how much, like how many mgs of them, like how much mass of these do I have. So if we were to think about having your big protein and your little protein, what's the same amount? Like, are we talking, if we talk in terms of mass, then we're going to have a lot more tags with this little guy. And so we're going to talk about molarity. So a mole is just 6.02 times 10 to the 23rd. This is Avogadro's number. So it's like a dozen, except it's a lot bigger than a dozen. And if we say moles per liter, so like a concentration now we're talking in molarity. So 1 mole is 1 mole per liter. Typically we're dealing with like micro nano molar type things when we're talking about protein concentration. So like a millionth of a mole or a billionth of a mole. So this whole thing kind of came up when I was doing this. I was purifying, so we use a lot of that TEV, so I was purifying the TEV. And I was curious, like, how does my TEV compare to the store-bought TEVs? So this TEV protease. So I looked, so this basically, if you look at the literature, the little thing that comes with your package, you can often order different like sizes. So the sizes are typically given like the units. So this, when you has an S here, that's like a small, then they have an L, which is like a large. And what you'll see is sometimes when you order these, it doesn't even say like what the volume is you're getting. It'll tell you the size, like the amount of units. And so this is like your total activity. How much doing ability are you sent? And so how much total ability activity is in the tube. If you want to know how many microliters they're actually sending you in that tube, if you look at the concentration, so the concentration, when they're talking about the concentration here, this is kind of like the enzyme activity. So units per mil. So this is 10,000 units per mil. And so this is like telling you how diluted is that activity. And so then if you use your molar unit conversions more in another post, then you can see that you have 100 microliters in this tube. And you have 1,000 units in this tube, and you have 10,000 units per mil. But what is a unit? So then you have to go and see what their definition of the unit is. And what's really, really frustrating is that they don't put this into the little package insert. So you have to go look it up online. What's even more frustrating is that when you go look it up online, you see that the unit is defined as being able to cleave 2 micrograms of BP fusion protein and BP TEV, blah, 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 to 95% completion, and then they get the reaction conditions. But their substrate is in terms of mass. So now, if you want to find moles, because we care about moles, remember, because a big protein is going to, and a little protein, they're going to have very different masses. So if you have this go by equal weights, now you're going to have a much higher number of tags that you need to cut off on this little guy, and they're going by weights. So if I want to find out the moles, well, now I have to find the molecular weight of this. And so this means I need to go find what the heck this is. So I look up this, and it's discontinued, but I can still find this and get its molecular weight. And so for proteins, we often have this, this molecular weight is often given in Daltons or kilodaltons. And so a Dalton is a gram per mole, and a kilodalton is a kilogram per mole, or 1,000 grams per mole. And so this is says it's 69,710 Daltons, which is 69.7 kilodaltons, or 69.7 grams per mole. And then I do more unit conversion and I find out that this is basically saying about 29 picomoles per hour of substrate. And now I can put this all together to get that there's about 29 picomoles per hour per mil. So that was a lot of work, but at least the NAB actually tells you what their substrate is. Sigma defined a unit as of TEV as 1 unit of TEV protease cleaves this blah, 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 of 3 grams of control substrate. Yeah, so they don't even tell you what their substrate is, so you couldn't even do that. And yeah, so NAB did good with that one. Well, they made me, I had to go through some hoops to find that stuff. But for their EcoR1, so this restriction enzyme brochure, basically they define their unit as the amount required to digest 1 microgram of lambda DNA and this reaction volume and stuff. And then the same unit definition is given for HND3. And so, but just like proteins can have different molecular weights, so can DNA, and it can have different numbers of cut sites. So these restriction enzymes recognize specific sequences. And if this lambda phage, so it's bacteria infecting virus. And so basically it'll have different numbers of cut sites for these different enzymes. And so I had to look elsewhere to find out that this DNA has 5 EcoR1 sites and 7 for HND3. So HND3 has to do more work per unit, but they cost the same. So HND3 kind of gets a raw deal. So the biochemist gets a steal. And one final note, when there are lots of variations, you can use the batch number printed on the tube to look up the certificate of analysis. And this should give you more information. This is more the case when you have, if you're ordering something that's a little like more technical, or like, yeah, not typically, I don't know, like there's been a couple times where like you order a protein and then there's like differences or whatever that you can see in the certificate of analysis. But typically for like these restriction enzymes and stuff, it's just like a pass fail type of thing that they tell you. And but for like things, if you were ordering like a kinase or phosphatase or something, that might have more specifics on the actual amounts of activity and specific activity. But when you buy it, they're basically like telling you how much activity is in the tube, and so you buy the amount that's in the tube type of thing. Okay, so hope that helps.